Alright, so before the day gets away from me, I'm going to do a video here. Looks like my video capture device is bugging out here, so let's try to fix that. If possible, I guess I can always use my... Okay, so hopefully we can get this working here. Ah, perfect. Okay, so... Yep, before I let the day go by, it's already 2 and I haven't done a video yet, so let's do a video. Now, I'm not sure what this video will be about. I know the last video was about scheduling, but I don't exactly remember how far I went, so I think what I'm going to do is just go and watch the last part of that. Oh, another subscriber. Thank you, thank you, thank you. So let's go and oh, and a bunch of messages. Hopefully not porn messages. I get a lot of those. I've been okay. Sweet, real messages. Okay. Well. Oh, there is one porn message. Okay, so let's Oh, it might have been, because sometimes you, like, report the porn messages and they say, like, oh, it's not porn. So they allow it to be reposted later or something. But, welcome, John Stem. Going to, oh. Yeah. I thought I had... I think you might be looking at 961. Let me see what I got, because I definitely went over that. Or yeah, that might be only on 960, not 961. Ah, no, here it is. Yeah, I have a playlist. Yep, I've got a whole playlist for that, so how do I share the playlist? Alright, back when I had much more stylish back then. Okay, so yeah, these two playlists. I think PyEZ was that would have been here, right? No, I did do PyEZ. I think it was Hi John, yes, I went over those topics in earlier videos. Check out the following playlists. Another thing you might find interesting is an OP script I made to search through the on-box help should probably have more like instructions for how to use this, but it's in a video. It's in a video somewhere. I forget which one. I have so many videos and they're all horrible. But I have instructions for how to use that in a video I did. In earlier videos, check out the following playlists. The thing you might have is, I think, I'm not sure what kind of role automation will have on the exam. I'm thinking that it will simply show up as a. I'm thinking that it will simply be a tool you can use to help you pass, as opposed to a specific scenario where you are required to use it. Something. Or are you required to use something like easy? Automation. I don't really have plans for it currently, but I did go over it and okay, I think this is a good enough reply, so there we go. Hopefully that's good. Oh right, so I wanted to look at the last one I did because I have no idea what I did in the last one. Oh, okay. Oh, did I forget to upload it? No. Oh, but I'm using a different, oh. No. Okay, so this is classification. Right now I'm learning about scheduling. So I moved on. Yep, sure enough, it looks like I forgot to upload scheduling. Yeah, so the good news is I'm doing it different how I used to. I used to do it with like a Zoom conference, so if I forgot to upload, I was completely out of luck. But I can upload this right now. So it's going to be in my local files. Yep, and I would have done it yesterday on the 31st. So So here's the video.
Alright, welcome to a special Halloween episode. I don't really have a costume. I guess I'm going to be a overly ambitious network engineer. Sounds scary to me, especially if I'm signing up for a test like the JNCIE-SP. I think I've got the scariest costume on of them all. So in addition to that...
That's such a good joke. Okay. I cracked myself up. Alright, so... yeah, let's see where I got. Oh, I'm surprised it's only like a half an hour video. Oh, you know what? Oh, I remember. Yeah, because I wanted to take a break from it. Yeah, I kind of did myself a little bit of a disservice yesterday by accident. I thought I could just take a break and come back to it. But in doing that, I accidentally just never came back to it. But this can be uploaded as a part 1, and then in this part 2, I'll do what I meant to do yesterday. Unfortunately, that does mean I'm a day behind. But let's give it a shot. Shoot. Okay, so unfortunately I've got to spend some time uploading the last one because I forgot about that. The good news is I know exactly what I'd like to do. I would like to finish these here. Okay, so this is configuring class of service schedulers on a security device. So we're going to be shown how to configure CoS schedulers on a device. An individual device interface has multiple queues assigned to store packets temporarily before transmission. To determine the order in which to service the queues, the device uses a round-robin scheduling method based on priority and the queue's weighted round-robin WRR credits. Junos OS schedulers allow you to define the priority, bandwidth, delay buffer size, rate control status, and RED drop profiles to be applied to a particular queue for packet transmission. You configure schedulers to assign resources, priorities, and drop profiles to output queues. By default, only queues 3, 0, and 3 have resources assigned. Note: Juniper network devices support hierarchical schedulers, including pure unit schedulers. In this example, you configure a best effort scheduler called a BE scheduler. You set the priority as low and the buffer size to 40. You set the BE scheduler transmit rate remainder percentage to 40. You configure an expedited forwarding scheduler called EF scheduler and set the priority as high and the buffer size to 10. You set the EF scheduler transmit rate remainder percentage to 50. Then you configure an assured forwarding scheduler called AF scheduler and set the priority as high and buffer size to 45. You set an assured forwarding scheduler transmit rate to 45. You then configure a drop profile map for assured forwarding as low and high priority. Diffserv can have a RED, I forget what that stands for, round robin, I forget what that stands for, drop profile associated with assured forwarding. Finally, you configure a network control scheduler called NC network control scheduler and set the priority as low and buffer size to 5. You set a network control scheduler transmit rate to 5. Okay, so let's do a search on RED, because I forgot that what it means. I think it means like round robin. Oh no, sorry, random early detection. I should have known that. All right, so let's start. It looks like it's just on one router. So unfortunately, we've got no verification steps other than just doing a show class of service. So maybe that's not just such bad news because I'll be able to get through it quick. So yep, let's do it. Yeah, I'm still kind of bummed out because I really thought that the what I was doing before would work, and I never went back and tried to figure it out. So before what I was doing, if I go on router 2, oops. So you can see here I've got class of service set up already because I was trying to oh no, actually this, never mind, this is from a different one. Before this one I had tried to set up a classifier to look at all packets with the do not fragment bit set and deny all those packets, and for some reason it just wasn't working. Kind of wish I knew why, but yep. So, but for now, let's just keep going on this new topic. I'm really only a few days away. By next weekend, I'll have all the topics learned. So, yep, that'll be good. Then I can do full day, 6-hour scenarios. They'll probably give me like a lunch break or something like that. So I think what I'll do is, let's see here, 9, 10, 11, 12. So yeah, I'll start at 9 next week. And then 12 o'clock, I'll take, I don't know how long we'll break, maybe an hour? I'm not sure how long they'll give me. And then 1, 2, 3, 4. So yeah, if I start at 9 and then I take I guess I can take an hour break and then come back at 1 and work until 4. I think that's a good plan for next week Saturday, and then just use the example table of contents in one of the free workbooks I found, and just see how far I get, and anything I can do perfectly, great. Anything I completely forget, then I can go over. So I'll give myself kind of a test grade doing that. But for now, we still got to get through all the topics. Oops, so it looks like I can't set the remainder transmit rate to 40 for some reason. Let's take a look at that closer. Okay, so I can enter the remainder command, but I can't set a specific remainder. I'm not sure what remainder is there by default when I set it. You know what? That might just be. I'm thinking that might just be a mistake. They accidentally added it there, but here they specifically made it 50. So I guess I'm not sure what the difference is between having it and not having it. But we're of course not going to be able to have it. Oh, you know what I might have done? Maybe I did it under... No, I did it under transmit rate, so yeah, I'm not sure what's going on. Oh, what the heck? Now I've got transmit rates. Like it's not. Oh. Oh, I see. Because percent. So for percent it will work, but for remainder it won't. Okay, so let's do a top and then go here. Okay. Alright, so we've got a EF scheduler, so it's time to move on to the AF scheduler. Alright, so that's the AF scheduler's got a percent as well. I think I actually already configured the AF scheduler. Yeah, so I've got the AF scheduler already. Looks like I've got 3 lines of code for each of these. Oh, I see, because this gets separated into 2 commands. Okay, so far everything looks good, except I can't set a specific remainder, but hopefully I won't need to. So the AF scheduler is going to require a few extra lines. Okay, so here's our scheduler. We've got multiple schedulers, BE, EF, AF. AF scheduler is going to have a drop profile map. And then we've also got a NC scheduler. Alright, so let's submit that and then do the verification step. There's only one. Oh my god, okay, so oh, well, of course. AF normal. Yeah, so this is what went wrong. They have a drop profile here, so what they're doing is they're calling the drop profile in, but they haven't defined it, so clearly that's not going to work. Okay, so let's see if I can just come up with my own drop file profile. Here we go. Yep, so let's make one named AF normal. And then we'll set the fill level to 99. Okay, and now let's see if it commits. Oops, so in addition to the fill level, we're also going to need the drop probability. Okay, so let's make it 50%. Alright, so we're not done with that. We've got another drop profile map that was called but never defined. So let's make a new drop profile map and assign it different probability and whatever the other thing was. Fill level. Okay, so last one we had fill level of 99. Let's make this fill level of 5. And then let's set the drop probability to 75%. Okay. Yes, and it commits. So time for the verification steps. Oops, so looks like that's not a valid command. Unless you give it more information. Let's take a look at our drop profiles. So we've got 3 drop profiles, it looks like. We get default, but then we have our custom profiles. Okay, so in addition to a drop profile, we also have schedulers. So let's see if we can look at our schedulers. Oh, we do have a scheduler map, so let's look at that. Here we go. So here's all our scheduler maps. We've got a default map. We should have a custom map as well. I wonder if it will give back all the maps. Nope. Okay, let me make this easier to read. Okay, well, I don't see the name I gave it. I'm pretty sure the name I gave it didn't have default dash in front of it. Unless it did. No, it was EF dash scheduler. So, oh, you know what? Huh. Yeah, it looks like they put default in front of it. Huh. Okay, so yeah, that looks good enough to me. I think that's enough to know what a scheduler is. So just to review, a scheduler is something that defines the property of output queues. These properties include the amount of interface bandwidth assigned to the queue, the size of the memory buffer allocated for storing packets, the priority of the queue, and the random early detection RET drop profiles associated with the queue. You associate the schedulers with forwarding classes by means of scheduler maps, and we have a scheduler map. Let's take a look at that. Okay, so we're associating schedulers. So here's we got our AS scheduler with forwarding classes. So I think this is our forwarding class AF normal. Well, I guess I don't see, because I would think that it would be set class of service forwarding class. Yeah, like I never made a forwarding class, so I'm confused. Yeah, there's no forwarding class, so I'm not sure what I did if I didn't associate it with a forwarding class. Maybe you can associate it to other things besides forwarding classes and not just forwarding classes. You can then associate each scheduler map with an interface, thereby configuring the hardware queues, packet schedulers, and RED processes that operate according to this mapping. An individual device interface has multiple queues assigned to store packets temporarily before transmission. To determine the order to service the queues, the device uses a round-robin scheduling method based on priority and the queue's weighted round-robin WRR credits. Juno's OS schedulers allow you to define the priority, bandwidth, delay, buffer size, rate control status, and RED drop profiles to be applied to a particular queue for packet transmission. You can configure per unit scheduling, also called logical interface scheduling, to allow multiple output queues on a logical interface and to associate an output scheduler with each queue. Note for Juniper network devices, when configuring the protocol parameter in the drop profile map statement, TCP and non-TCP values are not supported. Only the value any is supported. Okay, and we're not using any of these on the test. So, is transmit rate going to be next? What's the next topic? Queuing. Okay, so yeah, let's continue to read this whole thing. So I'm just going to read the rest of, oh my god. Shaping rate, scheduling properly. Buffer size. Yeah, you know what? I'm just going to read this whole thing. It's going to be painful, but I think it'll be important to know. So, alright, so starting with transmit rate. The transmission rate determines the traffic transmission bandwidth for each forwarding class you configure. The rate is specified in bits per second, BPS. Each queue is allocated some portion of the bandwidth of the outgoing interface. This bandwidth amount can be a fixed value, such as 1 megabit per second, MBPS, a percentage of the total available bandwidth, or the rest of the available bandwidth. You can limit the transmission bandwidth to the exact value you configure or allow it to exceed the configured rate if additional bandwidth is available from other queues. This property helps ensure that each queue receives the amount of bandwidth appropriate to its level of service. The minimum transmit rate supported on high-speed interfaces is 1/10,000th of the speed of that interface. For example, on a gigabit Ethernet interface with a speed of 1 gig, the minimum transmit rate is 100 kilobits per second, 1,000 megabits per second, times 1 divided by 10,000. You can configure transmit rates in the range 3,200 bits, bits per second through 100 160 million bits per second. When the configured rate is less than the minimum transmit rate, the minimum transmit rate is used instead. Note, interfaces with slower speeds cannot support minimum transmit rates, so I don't think we'll need to deal with any of those kinds of interfaces on the test, hopefully. Transmit rate assigns the weighted round-robin WRR priority values within a given priority level and not between priorities. The transmit rate defines the transmission rate of a scheduler. The transmit rate determines the traffic bandwidth from each forwarding class you configure. By default, queues 0 through 7 have the following percentage of transmission capacity. To define a transmit rate, select the appropriate option. To specify a transmit rate, select rate and type an integer from 3,200 to 160 million. No. That's not 160 million, that's 160 billion bits per second. Yeah, billion. Which is kind of funny because, like, as big as we think the number million is, it's only got 6 zeros. It's only got 3 more zeros than 1,000. And 1,000 only has 2 more zeros. 1,000 only has 2 more zeros than 1. So it's like, how big is a billion really? It's big, but a billion's a lot bigger. To enforce an exact transmit size, select rate. To specify the remaining transmission capacity, select remainder. To specify a percentage of transmission capacity, select percent, and type an integer from 1 through 100. Optionally, you can specify the percentage of the remainder to be used for allocating the transmit rate of the scheduler on a prorated basis. If there are still points left even after allocating the remainder percentage with the transmit rate, there are no queues. Then the points are allocated point by point to each queue in a round-robin method. If the remainder percentage is not specified, the remainder value will be shared equally. Delay buffer size. You can configure the delay buffer size to control congestion at the output stage. A delay buffer provides packet buffer space to absorb burst traffic up to a specified duration of delay. When the buffer is full, all packets are dropped. On Junos Networks devices, you can configure larger delay buffers on channelized T1-E1 interfaces. Larger delay buffers help those slower interfaces to avoid congestion and packet dropping when they receive large bursts of traffic. Okay, we don't need to read about the other kinds. We're only going to use MXs on this. To define a delay buffer size for a scheduler, select the appropriate option. To enforce exact buffer size, select exact. To specify a buffer size as a temporal value, microseconds, select temporal. To specify buffer size as a percentage of the total buffer, select percent, and type an integer from 1 through 100. To specify buffer size as the remaining available buffer, select remainder. Okay, so it looks like the documentation was incorrect. You would not include a number after this remainder because you're just saying whatever remains is what you get, so you would not specify how much of the remainder to get. I don't think it's worth a downvote because maybe they were using a special OS or something, but I'm tempted to do it. I haven't done it in a while, but let's just keep on going. I've got to get through this as soon as possible. Optionally, you can specify the percentage of the remainder to be used for allocating the buffer size of the scheduler on a prorated basis. By default, sizes of the delay buffer queues 0 through 7 have the following percentage of the total available buffer space. Note, a large buffer size value correlates with a greater possibility of packet delays. This might not be practical for sensitive traffic such as voice or video. For a Juniper Networks device, if the buffer size percentage is set to 0 for T1 interfaces, traffic does not pass. For various interface speeds, the default parameters such as buffer time, maximum buffer size, and maximum number of interfaces vary. When the traffic shaping rate is more than 1 gigabit per second, then 1 gigabit per second delay buffer is considered. Packets are dropped from the queue if the total buffer limit is exceeded. The queue size exceeds the total free buffer size. The packet buffer pool is less than 25% free and the queue exceeds the guaranteed minimum buffer size. The packet buffer pool is only 5% free or less. The queue size exceeds the guaranteed buffer size. RED profile condition, RED dropped, which stands for random early detection. The queue size will be restricted to less than or equal to the free shared buffers available. Scheduling priority. Scheduling priority determines the order in which an output interface transmits traffic from the queues, thus ensuring that queues containing important traffic are provided better access to the outgoing interface. The queues for an interface are divided into sets based on their priority. Each set contains queues of the same priority. The device examines the sets in descending order of priority. If at least one queue in a set has a packet to transmit, the device selects that set. If multiple queues in the set have packets to transmit, the device selects a queue from the set according to the weighted round-robin WRR algorithm that operates within the set. The packets in a queue are transmitted based on the configured scheduling priority, the transmit rate, and the available bandwidth. The scheduling priority of the scheduler determines the order in which an output interface transmits traffic from the queues. You can set scheduling priority at different levels in an order of increasing priority from low to high. A high priority queue with a high transmission rate might lock out lower priority traffic. To specify a scheduling priority, select one of the following levels. High, packets in this queue have high priority. God damn it. Low, packets in this queue are transmitted last. Medium-low, packets in this queue have medium-low priority. Medium-high, packets in this queue have medium-high priority. Strict-high, packets in this queue are transmitted first. Oh my god, okay. Next section is shaping rates. Shaping rates control the maximum rate of traffic transmitted on an interface. You can configure the shaping rates so that the interface transmits less traffic than it is physically capable of carrying. You can configure shaping rates on logical interfaces. By default, output scheduling is not enabled on logical interfaces. Logical interface scheduling, also called pure unit scheduling, allows you to enable multiple output queues on a logical interface and associate an output scheduler and shaping rate with the queues. By default, the logical interface bandwidth is the average of unused bandwidth for the number of logical interfaces that require default bandwidth treatment. You can specify a peak bandwidth rate in bits per second, BPS, either as a complete decimal number or as a decimal number followed by the abbreviation K, standing for 1000, M for 1 million, or G for 1 billion. The range is from 1000 through 32 billion bits per second. For low-speed interfaces, the queue limit values might become lower than the interface MTU, so that traffic with large packets can no longer pass through some of the queues. If you want larger sized packets to flow through, set the buffer size configuration in the scheduler to a larger value. For more accuracy, the 100 MSQ limit values are calculated based on shaping rate and not on interface rates. The shaping rate defines the minimum bandwidth allocated to a queue. The default shaping rate is 100%, which is the same as no shaping at all. To define a shaping rate, select the appropriate option. To specify shaping rate as an absolute number of bits per second, select rate and type an integer from that. It doesn't matter. I'm sure it'll tell you in the well, first of all, they'll if it comes up on the test, they'll tell you what rate they want it at, and second of all, well, I mean, there you go. So just type that in. I mean, they might get funny with you and say, oh, give me 1 gig and it's in bits, so you've got to know whether it's in bits or kilobits or megabits in order to get it right. But I'm pretty sure the question mark will make that pretty clear, hopefully. To specify shaping rate as a percentage, select percent and type an integer from 0 through 100. Okay, so let's put down in the notes what I read through, and I think that's going to be it for scheduling. So this video, how long has it been running? Oh, almost an hour, about 45 minutes. That's good enough for me. Let's include this in the notes as well. Okay, and then I'll just close these. Oh, did the other video get uploaded? It did. Okay, so yep, this is the conclusion of this topic. I gave it about an hour and a half of work. The next one's going to be scheduling. Oh, sorry, queuing. So thanks for watching, and I'll see you in the next topic, which will be about queuing.